So that's actually all I had for time series analysis. So that was a bit of a crash course and overview. Again, if you have any questions, pop them in the chat. We're doing quite well for time. We have about 45 minutes left. So we'll spend some time doing sequences, maybe a little bit of earth geometry. And if we get any time as well, we might do some exam tips as well. And again, anything we don't get through, it is in the slides down below. So please take a moment to download them when you get a chance. So what are sequences? Sequences are they're just a series of numbers, and they generally follow a pattern, unless of course it's a random sequence, because by definition, a random sequence doesn't really follow a pattern. But sequences, the type that we're looking at, they do follow a pattern. And there's two different types of sequences that we're going to be looking at: arithmetic sequences and geometric sequences. So, for example, because it follows a pattern, we can predict the terms. So, for example, the number pattern, 2, 4, 6, 8, 10. That is a sequence. We've already looked at a sequence together today, because that is a number pattern that follows a number sequence that follows a pattern. So I started with 2. 2 was my first number. 2 was my first term. And then what did I do to get to my second term? I added 2. And then to get to my third term, or my third number, I added another 2. And then I added another 2. And because it's following this really strong and predictable pattern, I can actually predict the next term by adding another 2, and then adding another 2, and then adding another 2. I can just keep going following this really good pattern. And the awesome thing about it as well is it does come down to substitution into formulas, some of which are on your formula sheet. So again, really super important to be really familiar with your formula sheet so you know what you need to know how to use, and you know what you need to memorize, because not everything is on your formula sheet. So that's our brief overview of sequences. Let's get into a little bit more terminology. So what I was kind of already introducing you guys to before earlier was the idea of term. I talked about our first term, our second term, our third term. What that is referring to is the fact that each number in the sequence is a term. So the first number in the sequence is T1. That's our first term. The second number in the sequence is our second term, so T2. This little n would be 2 in that case. Our third term, our third number would be T3, so n would be equal to 3. And n must always be a whole number. We can't have term 2.5. We can never have that, just because it messes with the rule a little bit, especially when we get into geometric sequences. So here, for example, what term number is term 8? 1, 2, 3, 4. So term 4, or T4, is 8. And another thing I'll draw your attention to is that sometimes T1 is also referred to as A. So that's just another terminology thing to be aware of. And the last thing you see in this example I gave earlier, 2, 4, 6, 8, 10. The ellipsis means that the sequence goes on indefinitely. So if you want to communicate that the sequence goes on and on and on, which they all do, because again, they follow that predictable pattern, ... implies that it just goes on and